Hello, this is Mr. Frank, and welcome to I Can Graph Transformations on a Coordinate Plane, Day 3. So, as you can see, we are pretty close to the end of the unit. We're going to have review and retake and summative coming up. Quick refresher. Transformation vocabulary. We need to know reflection. It's like you're looking in a mirror, so the images you can see here reflect each other. Rotation, that's when you're turning something. You can see we turn the Mustang Pride logo. And translation is when you move something. You need to know these three things: reflection, rotation, and translation. So all three of these things are called transformations. And you see transformations all the time in video games. So I know this one's popular, Agar.io. So what type of translation do you think you see here? Do you think you're seeing reflection, rotation, or translation? And I think you're seeing a lot of translation because the circles move around, so it's moving from one point in the grid, and you actually see a grid in the background, to another. And also when you shoot out a smaller ball to capture another one, what's happening is you're doing a transformation at a faster speed, and that's a translation. You're doing a translation at a faster speed. And then how about this video game? So here I picked this because you can see this car. There's a rotation going on here. So the rotation would be the type of transformation. And you see these types of transformations all the time in video games. You think the cop's going to catch them? Yeah, I think so. All right, let's do some practice. Let's start with this triangle. So this is triangle LMN, and we call it LMN because those are the letters that we put on each of the vertices of the triangle. And you can see the value of each of the vertices on the triangle. So I'm going to use that same triangle, and we want to rotate it 90 degrees counterclockwise. So counterclockwise means it's going this way. We're going to rotate it this way. You can see the yellow on the screen showing you how it's going to rotate. So we need a rule. We need a rule to figure out how are we going to translate our x and our y's in this rotation. So here's the rule. I'm helping you out here. So every time we start with x, y, and for a 90 degree counterclockwise rotation, we're going to change that to negative y and x. So I'm going to have you pause here and see if you can complete this and then come on back. Alright, welcome back. So let's see how you did. So point L is right now 2, 0, so that's right here. And we are going to rotate it 90 degrees counterclockwise. So the new coordinate point is going to be negative x, so that's negative 0 or just 0. I'm sorry, negative y, I should say, which is 0. And then x, which is 2. So that's going to translate to 0, 2. How about the next point? How about point M? So we're going to have negative y, so that'll be negative 3, and then our x value, which would be 2. And then our n value would be 0, 6. So we're following this rule here. So if you didn't get it, rewind and make sure you understand the way we get the new values for L, M, and N, L prime, M prime, and N prime, is to follow the rule where we write a new ordered pair using negative y and x. Assuming you understand, move on to the next slide. If not, please rewind. And here is what the rotation looks like. So remember how I said it's going to rotate from here to here? You can see that it's rotating, and it's rotating where we have the line MN here, and it rotates to M prime, N prime. And these are your new points. So now we're going to rotate 180 degrees. So 180 degrees, we've got the same triangle. So here are our points for the original triangle. Do you remember the rule for rotating 180 degrees? I'm going to let you pause here. You can look back in your notes to try and find that rule. If you're not sure, you can look ahead and then rewind and answer the question. But make sure you understand the rule for 180 degree rotation. Pause here and then come back. Alright, welcome back. So by now you should have the rule for the 180 degree rotation. It's negative xy translates to negative x, negative y. So this one's probably easier than the 90 degree rotation because we're just putting negative signs in front of the numbers. So 0.20 would become -20, and 23 would become -23, and 60 would become -60. So that is our 180-degree rotation. And if you want to see what it looks like on a graph, here's our original triangle, and then we're going to rotate it 180 degrees. So that's halfway around, 180 degrees, and we end up here. So all of our x values become -x, and all of our y values become -y. I hope you did well on that. Let's try another one. Now we're going to translate. Translate, if you remember, that's where we move. So we're going to move, and our rule here is we're going to move x -3, so that would be to the left, and we're going to move y -4, so that would be down. So translation is when we're moving something. So let's see if we have our original points here. Why don't you pause here and write what the rule is, and then find the new points for L prime, M prime, and N prime. So pause here, and then come back when you're ready. All right, welcome back. So our rule here is xy is going to become x -3 and y -4. We're given that information up here. So wherever I see an x here, I'm going to subtract 3. And whenever I see a y here, I'm going to subtract 4. So I end up with L prime of -1, -4, M prime of -1, -1, and N prime of 3, -4. So what I've done in each of these is I've taken my x value and I've subtracted 3. So 2 minus 3 is -1, and 0 minus 4 is -4. And I've done that for each of these points. And you can see what this looks like. With a translation, you're not changing the orientation or sort of the direction of the image. We're just moving it. We're moving the whole image here over 3 and down 4. So we can see it on the graph. If I move L, I'm moving it 1, 2, 3, and then down 4. 1, 2, 3, 4. So I get L prime. And when I do that for each of the points, I get this new triangle. So I want to show you some transformations. We see them in nature all the time. What transformation do you think we see with this butterfly? What do you see? Take a look. So I see a reflection. If you draw a line right down the middle, the butterfly is a perfect reflection of itself. You can almost hold a mirror up right here where I'm moving the cursor. If you hold a mirror up here, you'd still see the exact same butterfly because it is a reflected image. How about this? We see some animals in the wild. That to me looks like a translation because we've taken one image and we've just moved it from here to here. This may not be a perfect translation because they're not facing exactly the same way, but I think you get my point that that's a translation. And how about this one? This one could be a few different ones. You can see a reflection here. You could probably put a mirror right here, but you can also see a rotation. I can rotate this flower 180 degrees, and it would still look like pretty much the same flower. So I wanted to show you where we see transformations in nature. And here's a pretty cool picture. This looks like something you might see, something like this in a kaleidoscope. So I want you to find the transformations. So name and describe 2 different transformations in the image below. So you can choose from reflection, you can choose from translation, and rotation. So write down, so if you think it's one of them, write down and then describe the reflection or the translation or the rotation. And so you'll pause here, you'll write that down, and then you'll end up bringing it back to class tomorrow. So pause here so you can write it down and then come back. Alright, so by now you should have the 2 different transformations written down and describe them. Bring it to class tomorrow. And as always, if you can please answer the questions that you learned or were reminded of, and questions that you have are. Hope you enjoyed the video.